So our today's concern is with the two independent sample t-tests with SPSS. The two independent sample t-test is applicable when we compare the means of two unrelated groups on the same continuous variable, or we say which is a dependent variable. For example, if you want to compare the mean scores of therapeutic effect of patient receiving new drug or standard drug, we have one variable which is the score, which is a continuous variable, and we have two groups. One group is receiving the new drug and the other group is receiving the standard drug. Similarly, we have one more example with us that the mean we want to compare the mean scores of intellectual wellness between male and female. So male will be obviously an other group and female will be the other group. We are comparing the mean scores of intellectual wellness. Another example is to compare the average systolic blood pressure, which is again a continuous variable, between diabetic and non-diabetic patients. Or for example, we want to compare the hemoglobin level between the patient who are suffering with either dengue or with the chikungunya. Or for example, average scores of physical wellness between the student of public and private schools are being compared. These in this or scenario, we have to apply independent sample t-test. Before applying to the independent sample t-test, we have certain assumption. The first assumption is that the dependent variable must be continuous variable. Like in all the example we have discussed so far, like systolic blood pressure, hemoglobin, or the scores, these were all continuous variable. And the independent variable must have on two categories. It cannot be applied for more than two categories. You know, all the previous example like male, female, public and private schools. So all the example were had the two categories. And one more assumption is that the dependent variable, which is our continuous variable, should be follows normal distribution for each category. Like if we are comparing the blood pressure among male and female, so the blood pressure in the male category and the blood pressure in the female category should follow the normal distribution. We are going to use the normality using either Kolmogorov-Smirnov test or Shapiro-Wilk test using the SPSS. One more assumption is that the variance in each group should be equal, and the Levene test will help us out to find out whether the variances are equal or not. And SPSS produce this outcome with when we apply the independent sample t-test. To discuss the application of the two sample t-test, we have a scenario that study was conducted to compare the mean weight of the patient suffer with certain kind of disease with respect to their socioeconomic class. One class is low economic class, another class is the high economic class. Before going further, we have to check the assumption of t-test, which we have discussed in our previous slide. Our first assumption was that our data variable, our dependent variable, must be a continuous variable, which we can find out that the data variable is a continuous variable. And our next assumption was that our categorical variable, like our independent variable, must have two categories, and we have the category we have the variable economic class, which is two category. One is low class, another one is high class. Then there is one more assumption that uh, the data must follow, I mean, the continuous variable within each category should follow normal distribution, which we will check by using the SPSS. So I will take you to the SPSS now. We have entered the data in this form, like we have one variable which is EC, which is economic class, and the variable dependent variable is entered corresponding to each class. Like we have 13 observation of the low economic class and 30 observation from the high economic class. So we enter all the values which have the low economic class, and then we enter all of them which have the high economic class and the weight corresponding to it. We will go to the analyze, and in the descriptive statistic we have the explore function. We will click on it. We will transfer the weight variable in the dependent list, and since we have to check the normality within each group, we have to choose this option as the factor list. And we will go to the plot option. In the plots, we have this option normality plot with test. We will check it out. We will check it and we will press continue and then we'll press OK. The SPSS will produce too many table which we can discuss in here, that we have the concern with the table which says test for normality. So here, since our sample size is small, we are going to use Shapiro test, and the p-value in both category is more than 0.05. So we will say that our assumption of normality fulfills. So the weight of the patient in both low class and the high class follows normal distribution. This gives us the green signal to go for the two independent sample t-test. So we will draft our hypothesis as null hypothesis as mean weight of low and high economic class is same, and the mean weight of low and high economic class is different. It is our alternate hypothesis. Level of significance, it was not mentioned in the question, so alpha, we will take alpha is equal to 0.05. Test statistic, we are going to use two independent sample t-tests because our assumption fulfilled so far, except the one which we have not discussed so far, that is the Levine test. We will discuss it in the further. So rejection region will be reject S naught if p value is less than equal to alpha. For computation, we will go to the again the analyze, compare means, and independent sample t-test. In the independent sample t-test, we will transfer the weight variable in our test variable box. And when we transfer the EC, which is our economic class, in the grouping variable, it asks you define groups. Define group means we have to define the coding of the variable which we have given to our binary variable. So we have given the coding 1 and 2 in the category. So we will click on the define group and we will specify the value 1 and 2 and we will press continue and we will press OK. Once we press OK, we will get two tables. One table is about the independent sample test. The first column representing the output from the Levine test for equality of variance, and the rest of the column are from the t-test for equality of means. Our major concern is basically to use this p-value, but there are two p-values which one to use. This depends on the output of the Levine test. Again, if the p-value for the Levine test is more than 0.05, we will say the variances are equal. If it is less than 0.05, we will say the variances are not equal. Here, the p-value is 0.251, which implies that the variances were same in both groups. So because the p-value were more than 0.05. So then when we have the equal variances, we will use this p-value. If the variances are not equal, for example, if we have the p-value less than 0.05, we will use this p-value which is given in the next row. So we are using this p-value for the t-test, which actually compare the means of the weight of the low and high economic class. So this p-value is also more than 0.05, which is more than alpha. So we conclude that we fail to reject the null hypothesis that the weight of low economic class and the high economic class are same.